thing that I'm going to talk about is function. We call functions. Now, I tell this every time I teach this. This is something I had difficulty wrapping my head around when I was your age. I couldn't understand what a function was. So if you don't understand, I will explain it over and over again so that you actually understand what a function is. Because so by definition, a function. So write this down. For every x value, there is one and only one y value. Okay, that's what a function is. Now, we have just spent the last 3 days working on relations. And a relation is, just as it says, a relationship between the x and the y values. All right? The y value is dependent on what the x value is. So that is a relation. Now, all functions are relations, but not all relations are functions. So we're going to get into that as we go through this, and I'll make it make a lot more sense as we go. A relation is classified as a function if each value in the domain corresponds to exactly one value in the range. That's what I'm talking about right here. So for every x value, there is one and only one y value. All right. Now, how do we check this from a graph? This is the easiest way to explain what a function is. If you draw a line straight up and down on the graph, and if it only hits one spot on the graph, it's a function, because that means that there's only one x value, only one y value for each x value. So let's have a look at a couple different types of graphs that are functions. Okay, so graph number one, that's a function, is just a line. So if I take if I take this line right here, a vertical line, I draw it up and down. Notice that it only hits one spot on the graph at all times. So therefore, that line is a function. Another example of a function is this guy. Because again, when I take this line right here, grab it, it only hits one spot on the line.
Like positive?
Just ignore the straight line, just a curved line. It only hits one spot on the curved line. Now, I'm going to show you an example that is not a function. Oops, I want to choose a color.
What do you mean by it only hits one spot? What part?
Okay, let's do this on a separate page here. Okay, so here's the graph. There's your grid. My graph is that right there. Okay? So there's my graph. Now the equation of that graph. I'm just going to do this. The equation of this graph is y equals x squared. So I get the y values by putting in the x value and squaring it. So for example, that right there is 1. That's my x value. Well, what is my y value? What's 1 squared? 1 squared is 1. When x is 2, what is y? 4. So up here would be 4. Okay? When x is 3, what is y? 9. So I just put it in there. The same thing occurs over here. When I put negative 1 in for x, what is negative 1 squared? No. Positive 1. You're squaring the whole thing. Negative 1 times negative 1. What is negative 2 squared?
No, positive 4.
Positive 4. Negative 3 squared?
Positive 9.
Okay. So I plugged them in, and we're going to learn all about this today. So now, I take this line right here. And I move it across this red graph. Does it ever hit any more than 1 point when I come across this red graph?
No.
No. That means that for every x value along this graph, there is only one y value. That means it's a function. Now let me show you what's not a function so that it makes sense. If I have a graph that looks like this, that's not a function. Why? How come? Because when I move this line here, how many points does it hit on that green graph?
2.
2. Therefore, that's not a function. All right? So if it hits more than 1 point on the graph, it's not a function. Circles aren't functions. All right? Because you would hit more than 1 point when you do a circle. So let me just show you that. There's a circle. How many spots does it hit here? It's 2 there. So if it hits more than 1 point, it's not a function. Again, this is going to be hard for you to get your head wrapped around. So we will work through this a little bit slower. Go ahead, Blake.
What if it's like a line straight up and down?
Not a function.
Not a function.
No. Now watch this. Here's another one. And you're going to spend some time today doing this. But watch what happens here. What if I have dots? Okay. Same idea here. Same principle. Take a line. Draw it through. How many dots does it hit there?
1.
1. How about there?
1.
Here?
1.
Here?
1.
Here.
1.
So in every case, you only hit 1 dot, right? Therefore, it's a function. But what if I had this? Still only hits 1 dot, 2 dots, 3. Uh-oh, what happened there?
2.
Not a function.
It's not a function because it hit 2 dots. Now, let me explain this in terms of coordinates. Okay? So I'm going to explain this in terms of coordinates. All right. This is 1 right here. This is 2 right here. Okay. That coordinate. You remember how to write coordinates? This is also something we have to go through. Coordinates are written as x first, y second. So what is that coordinate right there? 1 and 1. That coordinate? 2 and 1 right here. What about that one? 2 and 2. This one? This one? And this one. Okay. Now looking at those coordinates, is there anybody in here that does not understand how to write a coordinate? Put your hand up if you don't. X, Y.
I do. I have a question with that. So like when you have like the dot one where it's like that, I understand like it's 2 dots, but like what about that? You mean the 2 lines? Or you mean the 2 dots on the lines? Like on the second answer.
Okay.
It's like how do you tell whether that's a function if you just had those 2 red lines?
If I just had these.
2 red lines with the dots, so you still compare it with the dots on the line?
Yeah.
Oh,
Yes.
so even if there's 2 lines and they don't match.
Well, 2 lines, we're only going to look at one graph at a time.
Like when you have like the green and the red there.
Okay, so this is 2 separate graphs, so I have to check both of them. Green and red, go ahead.
So like you have those 2. What if the dots don't line up? Then it's just still a function.
No, it is if it is. Okay, let me explain it here and see if we can get it. Okay, so looking at these coordinates here, anywhere in here, does the x coordinate have different y coordinates? Are there any x values in there that have more than one y value? Which one? 2. 2 and 1, 2 and 2. So if the x value has more than one y value, not a function. not a function, because it doesn't pass this test. It hits right here and it hits right there. All right, now they are all relations. The x and the y have a relationship, but they are not a function, because you have right here, this x value of 2 has more than one y value, not a function. I'm going to go back to the graph I just drew you. Y equals x squared. X, y, I'm going to put in some coordinates. Those are the coordinates. X is minus 2, y is 4. X is minus 1, y is 1, 0, 0, 1, 1, 2, 4. Do any of the x values in there, do any of those x values have more than one y value attached to it?
Yeah.
Which one?
-2 and 4.
None is the correct answer. Here's your x values here, right? Do any of the x values have more than one y value attached to it? Right. These numbers here, the y values can be the same, but the x values have to be only have one variable, one number with it. So what's the difference then? Let's just take a look here. All right. Let's look at the difference here. In this one here, if I were to write that out, let me do this. Maybe this will help make more sense of it. Do any of the x values repeat themselves and have different y values?
Yeah.
Yeah. The 2 has a 1 here and the 2 has a 2 here.
So as long as the x values repeated.
Only if the x values are repeated and have different y values. That is correct. Any of the x values repeated there? No.
What if it was negative? Instead of -2, if it's +2.
Yeah, if this was a +2 and a 4 and a +2 and no, that would have to be a different y value. You have to have. So let me look. I'm going to show you. I'll go back to this other graph that wasn't there. Okay. So here's one that is not, and I'll do a table of values for it. Okay. Any of the x values repeat on there? Which ones? 4's on there twice. Agreed.
One's on there.
One's on there twice. Do they have different y values?
Yeah.
Yeah. So this doesn't pass it, does it? Well, we also have this to check it. How many points does it hit there?
2.
It's 2, not a function.
So if there's 2 the same.
There's 2
if
x
you got
values.
4 on there, it's not the same.
That's
And then
correct.
There's only one, like the other one that is. it is
Yes.
one.
Okay, so do we see the difference between these two? This one hits more than one point. It hits a point right there and a point right there. Not a function. This one, doesn't matter where I draw my line, it will only hit one point. Therefore, it's a function. Okay, now why is it so important? Why is it so important that we understand what functions are? Well, when we start graphing them, we're going to have what we call an input and an output. So I want you to look at page 126. Each function has its own formula or rule. which is often using a special notation called a function notation. For example, okay, to begin with, I'm gonna do a different example than the book. Just for a second, I'm gonna go y equals 2x subtract 2. Okay, that's the equation of a line. We drew lines last year, yes? Right, we've done some of this. Okay, so to find out how to draw the line, there's 3 different methods we can use. But for today, all I need you to know is the second method, or the first method that we're going to use is the table of values. So I'll explain that in a second. But here's the thing. Here's the equation y equals 2x subtract 2. We see that there's a relationship. To get my y, I take the x value, I times it by 2, and I subtract 2. That's how I get to my y value. So, for example, 0, 1, 2. To get my y value, I put that value for x into the equation, and then I times it by 2, and then subtract 2 from it. So what's 2 times 0?
0.
0. 0 subtract 2 is?
-2.
-2. So that goes here. So that is right here. Okay, let's put 1 in for x. 1 times 2?
2.
2 subtract 2?
0.
That's right here. All right. 2 times 2? 4 subtract 2? 2. That right there is a relation. Is it a function?
Yeah.
How do I know it's a function?
Because it only touches 1.
Beautiful. It passes the vertical line test. If I take that vertical line again, and I drag it anywhere along there, how many points does it hit at any time?
1.
It just hits 1. So it is a function. Now, here's the first thing that is brand new to you today. To tell somebody that a graph is a function, we take the y equals out of there and we put in a function notation. Now it's just a notation. It still means y, but it's just going to look a little bit different. So here's a function notation. F of x equals 2x subtract 2. Now, why do we do that? Now, again, the grade 11s and 12s struggle with this all the time. All right? We change y to f of x to explain to somebody in math terms that will pass the vertical line test. That for each value of x, there's only going to be one value of y, no matter where I go on that graph. That's how that works. Once you see that, understand that that is just y. So instead of writing y up here, I'm going to change that and put f of x in here. Now, the x part of this is what we call the input. The f of x part is the output. So we put it into the function for x, and we output what f of x is. So for example, I didn't even finish this. There. No, that was 2, wasn't it? For example, here's what happens. I want everybody, f of 2. Whatever's in those brackets right there, you substitute into the equation for x. Substitute it into the equation for x. So 2, 2, subtract 2. What was 2 times 2? 4 subtract 2. So f of 2, this says when x is 2, y is 2. That's what that says. It just is a very mathematical expression. Okay? let's look at, let's use the example that they've got now. So they do P of X,
That's just F for us, right?
means the same thing. 2x plus 8, and they want when x is equal to 3. So I put in P of 3 equals 2 times 3 at 8. So the input value is 3. So what do I do to it? I times 3 by and plus 8. What's 2 times 3? 6 add 8? 14. So when x is 3, y is 14.
So then your x could change though.
Yeah. So this is the independent variable. The y is the dependent variable. It depends on what x is. I will change what x is, and then I will solve for what y is, because y is dependent on it. So let's look at an example that might mean something more to you. It says, distinguish between relations and relationships that are functions and those that simply relate in input-output manner. We must consider all the possibilities of the domain. Okay, so the relationship is I work for $8 an hour. The domain input is hours worked in 1 week. The range output is the amount earned in that week. Okay, so let's set up two things. Let's set up a graph first and then an equation second. Okay, so here's how this works. Across the bottom is going to be the number of hours worked. Number of hours. Number of works. And then this is his wage. Okay. 1, 2, 3, 4, 5, 6. If he works for 1 hour, how much does he make?
$8.
$8. If he works for 2 hours, how much does he make? $16. If he works for 3 hours,
34,
$24. If he works for 4 hours,
32,
32.
What's the next example?
40.
Okay? So what's happening here? What's happening here? Depending on the number of hours worked, we can find out how much money he makes. Is this a function or is this not a function? It is a function. Because there's no way to get 2 y values for 1x. Because he makes $8 an hour.
Quit my job.
Yeah. You got no idea, buddy. All right, wage. So I'm going to go W of H. I'm going to write this out as a function.
Is H hours?
H is hours. W is wage. How do I find out how much he makes? What do I do?
Input for H.
Input for the H and then do what to it?
Times by 8.
Awesome work. 8H. There's your equation for that. So if he works for 10 hours, how much money does he make? $80. If he works for 20 hours, how much money does he make?
160.
$160. So the input is whatever the H is, the number of hours. The output is how much he actually makes. That's a function. Okay? Because I can't double up a Y for an X. Putting footwear on before leaving the house. So you got to choose a pair of shoes, leaving something on your feet. That's dumb. Baking bread? Nope. Studying for a math exam? Okay, let's try it. Studying for a math exam. The number of hours versus the mark on the exam.
Of course, we're doing the math.
Is that function or not a function?
Function.
You think it's a function?
The math one?
What if I study for 5 hours for 3 separate tests?
That's it all.
It would not, because it'd be more.
Because why?
They'd all
Would
be
be
the
more
same
Y.
amount.
You have
More
3
than
different
one
results
Y.
you can get.
Yeah, attaboy. Okay, 100%. Good job. Okay. What could happen If I study for 5 hours for a test, for 3 separate tests, I might get an 80, I might get a 90, I might get a 40. The number of hours doesn't directly correlate, does it? Okay? Is that a function? If it's possible to have more than one mark for the number of hours. No, it's not a function. Okay, that's great. All right. That's it. I'm going to let you do the rest. And then we will get, on Monday, we get into slope. And then we are going to skip, actually, we're going to we'll have one assessment on it, probably an assignment next week. And then we're going to get into the next section because I want to finish it up before Christmas. So that's chapter 7, and it's all on graphing. So we're going to assess once, probably on Tuesday-ish, and then we're going to get chapter number 7 done after that.
So basically 6 and 7 are not together.
6 and 7 are tied together because they're both graphing. This is the start of it, and then we're going to. Okay, look back at yesterday's work. I had asked you to get a number of things finished yesterday. Are there questions from yesterday that we want to look at? Kaylin, if you have questions, put them in the chat, and I can look at the chat.
That was some secret.
Yeah, type it in the chat if you have any questions, Kaylin. All right, any questions in here from yesterday's work? Any questions in here? You got a lot to get through here. Which page? Yeah, okay. I'm not a huge, this question annoys me. But, so here's what we're gonna do.
Which question?
6B. Okay. 6B.
Oh, like the.
Okay, so I have -3 as my low end of my domain. So I need a mark somewhere on that. Let's move this over a bit. So I need a mark somewhere on -3. And it can be anywhere, so -1, -2, -3. So, and it's gotta be an open dot. So I'm gonna stick it right there. Excuse me. Okay. Then my maximum value for my domain is 5. So I need a mark somewhere over here. I'll even put it right here. 1, 2, 3, 4, and 5. So I'm gonna put it right here. My range for that question, my minimum value is 1, and it has to include 1. All right. So what I'm gonna do, I'm just gonna move this guy up. I'll put it up here, and then I'll put another one right here. I guess I didn't have to move it up. There's the minimum value right there. I'll even move this guy up a bit, right to here. Okay, that should be at 5. So all I'm doing right now, Marissa, is just trying to draw dots to see. And then, so right now I have a minimum domain of -3, so I put it there. It has to be open because it doesn't include. A maximum of 5, which is over here, has to include it. A minimum of 1 has to include it, and a maximum of 5 not included. So I can put it anywhere. So this would be 2, 3, 4, and 5. I can put it up here. Doesn't matter. It doesn't include it, right? Okay. Now I can, whatever. Here. That satisfies that.
So it doesn't have to, it can be kind of anywhere.
Anywhere. You can draw whatever you want as long as your closed dots are here and your open dots are there. Okay. It's just using your domain range to help you with that. But so you can do that for C and D as well. Okay. And actually you could just use this design right here because they're all the same numbers. And then all you gotta do is close dot, open dot, just change those for C. Okay? Okay. Anything else from that page?
You do number 4.
Yes. Number 4, you said? Okay. With what we did today, do you think you can do number 4? All right. The cost is, so, hey, zip it. The cost for gasoline is 92 cents, and then the car wash is $8. What is the domain in this equation? Okay. So N is your independent variable. Agreed? Your cost is dependent. If you're looking at that equation, why did I come up with that? Why did I make that assumption? How do you find the cost of your gasoline and car wash? Sort of, yes. But here's what I'm saying, okay? How do I find my cost? What do I need to know in order to find my cost? Yes, which is my N value, right? So I need to know how much gas I have because that's going to be multiplied by 0.92, which is per liter, and then add the $8 after. So this C is the dependent variable. The cost is dependent on what? How much gas you use or buy, correct? Yeah? And then the car wash is separate. You add the $8 after. So the domain for this graph looks something like this. Starting here is 0 liters. Does it tell you a maximum number of liters? 40. So what is your domain then? Right. And does it include it? Yes. So your domain for this could look something like that. Could look something like this. Right? Does that make sense so far? Okay. What about your range here?
It'd be like 0.92 all the way to 40 times 0.92.
Okay. You're closer. You're close to what I wanted. All right. What if I have 0 liters? How much does that cost me? No. How much does it cost me? No. What if I don't get gas? I'm still buying what? Car wash. So if I have 0 liters, how much is this going to cost me? $8. So you're starting right here no matter what. At 0 and 8. If you have 0 liters, it's still going to cost you $8. Make sense? Okay. Now, you had it right. 40 times 0.92 plus 8. Right? So then your range would be what? What's the lowest it's going to end up being? 8. And then it goes up to whatever 40 times 0.92 plus 8 is for your range. Does that make sense? Okay. All right. Okay. 6.4. Go through it right now, please.
What number to be done?
I'll let you know. I didn't have Okay. Go ahead. Which questions? I'll let you know at the end of class here. Okay, I need you guys to sit down. I'm still working at the board here. So I need you guys quiet. Do not visit, do not ask questions. Give me the page number and the question number, Caleb.
Question 9, I'm confused.
Yeah. It done. Okay. Okay, here's how that question works, Caleb. So Les forgot to label the lines on this graph. Which line represents revenue? Which one represents cost? Okay. So if I need you to think about this. Let me do this on the board as best I can here. Okay, you guys need to work on your own quietly because your voices are being picked up here. So, okay. So Kaylin, if you do nothing and don't sell a single belt, you still bought all the belts, so that has to be the line. So if you sell 0 belts, it's still going to cost you $4,000. Okay, so that line that touches at 0 and 4,000, that's the line that it's going to cost. The revenue line is if you sell 0, you make no money. But as you sell belts, that's going to be the revenue for it. All right, so at some point, it's going to intersect, and at this point right here, so that looks like it's at about 500 belts. At about 500 belts, you're going to break even. After 500 belts, you're going to have more money than you are. You'll have more money than you will have spent. Okay, so what is the initial cost? The initial cost is, so this is B. The initial cost is 4,000. How many belts does the company have to make and sell to break even? That answers 500. What are the cost and revenue of the break even point? So the cost at the break even point is 500 belts is $9,000, I think, is what it looks like. It says, what is the predicted profit, the difference between the revenue and cost, if the belt company sells 1,000 belts? So if he sells 1,000 belts, he makes 16,000, and it costs him 13,000. So the difference would be 3,000 on that. How much would the company lose if, after setup management decided not to produce any of these belts? Well, they would lose $4,000. And then it says, what is the projected selling price of one belt? That you would have to take maybe the 9,000 and divide it by 500. And that would tell you what it would cost. Okay? Give me a thumbs up if that works for you. Okay. You have another question? Okay. I think that the best way to check that is to maybe draw out the coordinates So there's that, minus 2, and 2 is right here. Minus 1 and 0. 0 and 0. Okay, so I'm just looking at the coordinates here, Kaylin. And right there, at that point right there, I know it's not a linear relation. Because it has to give you a line, a straight line. So in A, it's a nonlinear relation. In B, I have minus 3, minus 5. Right there. Minus 2, minus 3. Right there. Minus 1, right here. 0, 1 right here. Okay. And I can keep going, and it's going to give me this right here. That is a linear relation. So it says describe in each in relation to words. So as you move to the right, you go up by 2. So for that B part, which is not an easy thing to describe, but each one I go up by 1 by, okay? I go up by 2. So it consistently goes right 1, up 2, right 1, up 2, right 1, up 2, all the way this way. Therefore, it's a linear relation. And then you can do C and D now, I think. So just graph it and see if it gives you a straight line. If it doesn't give you a straight line, then it's nonlinear. Okay. He's back. Number 4. Determine each formula. Okay, in order for it to be a linear relation, Kaylin, you have to have x, or the variable has to have an exponent of 1 on it. So in the case of pi r squared, because of the squared value, that's nonlinear. If it's linear, the exponent right here has to be a 1. So A is nonlinear, B is linear, C is nonlinear. Because if you take the n and you times it by the n in the brackets there, it's going to give you an n squared. So those are 2 of those are nonlinear, B is linear, because the S has an exponent of 1 on it. So the same thing goes for question 5. So A is linear, B is linear, C is not, and D is not linear. Okay? Anything else? The videos are on there for from yesterday. You want to look at that. Video store charges $4.50 to rent a new release movie. The store's owner wants to put a poster to make it easier for customers to determine the cost of renting multiple movies. Name the independent variable. Okay, so when you're doing this, the independent variable is always your x. In this case, it's your number of movies. The dependent variable is the cost. So describe the pricing policy in words. Each movie costs $4.50. So one, $4.50. Rent 2 movies, $9. You rent 3 movies, $13.50. So you're gonna have a linear relation that looks like this. So write an equation to represent the cost of renting 1 through 5 movies. Okay, so the cost is equal to $4.50 times the number of movies. Then to make a table of values, enter your independent cost, 0, 1, 2, 3, 4, and 5. There you have it. There's your table of values, that's E. Make a graph, I did that already. That should take care of that one. Okay? You all right on that one? Okay, perfect. Anything else? Okay, excellent. All right, hope you feel better. You can sign off now if you're done with your questions.
Most of us have done.